Here we discuss stream functions, which can only be defined for a two-dimensional incompressible flow. Alright, so for an incompressible 2D flow, again, what we can define is something which is called the stream function. And I'm introducing the stream function now because it's related to incompressibility, so you can only define it for incompressible flow, although we will mostly use the stream function in the second quarter when we start discussing potential flows and when we start discussing, when we start finding solutions for gravity waves and so on. So the stream function is just a field, it's a function, and it is useful in 2D because it allows us to, instead of solving for a vector field, which has two components, u and v, we can solve the flow and get the kinematics of the flow with just one function, which is called the stream function. So the symbol which is used for the stream function is the symbol psi, and because we're in 2D, we have two independent variables x and y, and psi of x and y is a stream function when contours of the function correspond to streamlines of the flow. So contours of psi correspond to streamlines of the flow. That is here the definition. So note that a stream function is a function and it is not a curve. Right, so psi here is a function, not a curve, and therefore don't mix a stream function with a streamline. A streamline is a curve. So what you do have, however, are that contours of psi, and contours are points such that psi of x and y is equal to a constant. So these are contours of psi. Now these contours are streamlines. These contours here are curves, right? And they correspond to streamlines. So we will, you don't know how to compute the stream function, we'll discuss that later, but let's take an example. And let's take a problem that we've seen before, a flow field that we've seen before, which is, again, not really interesting, but it does the job here, and that would be a solid body rotation. So we already know what the velocity field is. So the velocity field u, the x component is equal to minus omega y, and the y component is equal to omega x. So the velocity field here is defined at every single point. So at every single point here, I can attach one vector which has two components, and the component at a given position are given by this vector. Now note that the solid body rotation here is a 2D flow, and it is also incompressible. If you're not convinced that it is incompressible, let's just compute the divergence of u. The divergence of u is equal to partial u partial x plus partial v partial y, and partial u partial x of minus omega y is equal to 0, and partial v partial y, so partial omega x partial y is equal to 0, so the divergence is equal to 0, check. This is incompressible. Now the stream function associated with the stream function for solid body rotation, so the stream function associated with this velocity field, again, you don't know yet how to compute it, but I can give it to you, is a field. So it is a scalar which is defined at every single x and y, and it is actually equal to minus 1/2 omega times x squared plus y squared. So if you look at the shape of this function here, this is a function of two variables, and it is, so this is a paraboloid, and because you have a minus sign, it is an inverted paraboloid. So if I wanted to represent this this function, I would draw something like that. So I have an xy plane, so and the value of my function psi, right, depends on x depends on x and y. So to every single point in this plane, I associate the value of the function psi, and the function looks like an inverted paraboloid. So it looks like this, roughly. Right, so this here is a function of two variables, which is the stream function. Now, how does that relate to streamlines? Well, remember the definition. The definition of a streamline is the definition of the stream function. Psi is a stream function if contours of psi are streamlines of the flow. Now, a contour of psi is simply a curve such as psi of x and y is equal to a constant, right? And in our case, psi of x and y is equal to minus 1/2 omega x squared plus y squared is equal to a constant. These are contours of the stream function. And clearly you see that this equation now, so contours of the stream function, these are curves, and this is the equation here for a circle, right? And when we look at the solid body rotation, we know that a streamline of a streamline for this velocity field is indeed a circle. So here, contours of psi, these are the curves such that minus 1/2 omega x squared plus y squared equals to a constant. They do correspond to streamlines of the velocity field.